Dear students, very good morning. Today we are going to discuss about Introduction to Embedded System. It is our unit 1. So the topic is processor selection for embedded system. Okay, so first you have to understand how to choose a processor for an embedded system. Processor selection is not an easy task for an embedded engineer. It is not possible to simplify select processor from your favorite list. Several factors are to be considered while selecting a processor for an embedded system. Because of embedded systems are designed to operate in different climatic conditions and critical environment like digital signal processing and hazard system management, so like that. So what are the processor depending on? Processor, it may be depend on types of applications, the necessary performance, power constraints, special processing, modern technology. Then the processor is selected. There are different types of embedded processors are available in the market. The selection of embedded processors should enhance the user experience by reducing the chance of poor speed, system overheating, insufficient memory. So these three things are important. Uh, one is the chances of poor speed and system overheating, then insufficient memory. The embedded system in customer's hand should not make them curse the designer. Instead, the system should make them proud of the technology. Okay, so these are the constraints you have to concentrate on while choosing the processor. So what are the factors for for selection of embedded processor? One is the speed and performance, optimal power usage, then peripheral support, advanced pre-processing cost. These are the things we have to concentrate. Next one is the processor selection for embedded system, speed and performance, optimal power usage, peripheral support, advanced processing and cost. So now the speed and performance. The number of instructions executed per second and the number of operation per clock cycle must be evaluated for accessing the performance of the processor. Students, how the processor performance is accessed means the number of instruction executed per second and the number of operation per clock cycle must be evaluated for accessing the performance. Okay, so the advancement of fabrication techniques enabled the packing of more transistor in the same area, reduce the propagation delay. Okay, so next one is the processor architecture that support additional instruction can aid in improving performance for specific applications. Next important thing is pipelining and superscalar architecture boosts processor performance even further. Okay, so other techniques for increasing execution rate including branch predictions, speculative executions and so on. Okay, so multi-core processor are the new trend in performance enhancement of the processor. First, we have to concentrate on optimal power usage. So, increasing the logic density and clock speed have an adverse impact on the power requirement of the processor. More logic leads to higher power density, thereby making a heat dissipation as difficult with the more emphasis on greener technology, and since many systems are becoming battery operated, it's important to design a system for optimal power usage. Okay, so next techniques like frequency scaling and voltage scaling used to do power efficiency reduction. Okay, next one is the peripheral support. How we can choose a peripheral support. Apart from the processor, the embedded system has many other peripherals to perform input-output operations. It is important to have a right peripherals to assist the processor in optimized performance. Next one is, in recent days, almost all the processors used are SoC, system on chip design. So it is better if the necessary peripherals are available in the chip itself are called on-chip peripherals. So next we have to concentrate on advanced processing. What is mean by advanced processing? Along with the code, the presence of various co-processors and specialized processing units can add more value to the processing performance. The instruction fetched by the co-processor are executed by the co-processor in parallel, thereby reducing processing load. Some of the popular coprocessors including floating point coprocessor, graphics processing unit and digital signal processors, etc. Floating point coprocessor can be very helpful in applications involving complex mathematical operations including multimedia, imaging, codes, etc. So next one is advanced processing. GPUs are used to accelerate the 3D graphics in gaming applications, video and content creation, artificial intelligence and machine learning applications. So students, now it's the time for assessment. List the type of processor used in embedded system design, how to increase the speed of the processor, how performance of the processor is calculated. So thank you students.